Okay, class, I'm going to show you the answers to these two problems, and I want you to tell me what you think, okay? So the answer for this one is 4 root 3. Does that sound right? Do we need to go over it? Yes, okay. So, in Unit 2, we talked about rewriting the radicand, and the radicand is the inside of a radical. Okay, so write that one right here. The radicand is the inside. Rewriting the radicand, or the inside of a radical, in product form, okay, as a product of factors, okay? So that means, what times what is 48? Can you guys show me on your whiteboards? Give me a product. Two numbers that when I multiply them, I get 48. Yes. 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 Good. Yes. 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 Good. Waiting for a few more. Yes. Good.
Is there any other side?
Yes. Good.
Okay.
Yes. Good. All right, I like that. I'm going to write them down here. Okay? So these are my factors of 48. Okay. And some of you had different factors. Okay? I had a lot of 6 times 8. I had some 4 times 12. And I had one group that came up with 3 times 16. There is another pair that is missing. Ooh, 24 and 2. And there's one more that's still missing.
48 and 1.
48 and 1.
Check it
Okay, I'm going to draw this line longer. Okay, so those are all of our factor pairs. So now I want you to, without saying anything out loud, I want you to think about a factor pair that you would use if our goal is to try to square root something. Okay? Good. Yes. Good. That's what I would think. What is another pair you think we should? Yep, that's a good pair. Good. A lot of you are picking the best pair. I like it a lot. Okay. Okay. So a lot of you are picking this pair. Why is this pair the best for a square root? Now don't say anything out loud. I'm going to call on some. I want to see someone. Ashley.
You can square root the 16.
We can square root the 16. Now there's another pair where I can square root a number. I can square root a 4. Why are you picking the pair with the 16 instead of the pair with the 4?
No, because you can't square root 3.
Well, we can't square root the 3. That's a good reason.
She's not good. Give me a chance.
All right, I'll give you a chance. What do you think?
Because
Why
like,
that pair instead of the other pair?
Because the number you're not square rooting is lower.
Okay, so this one is smaller, and I can't square root it. I can't square root a 12 either, but this one has a smaller number that I can't square root, so I might have to simplify less. Allison?
Well, you don't have to do as much simplifying because you just square root the 16 and then it gives you your.
So she's saying kind of the same type of thing but in reverse. So William's saying this one I would have to simplify less if I have less left in the radicand. And Allison is saying, well, if I take more out initially, then I'm going to have less simplifying to do, less steps to do. Okay? So two ways of thinking of the same concept. Okay? So I agree that one is the one that is the most efficient. But it's not the one that most of you would have done. How many of you honestly thought of this pair before we listed any products? How many of you thought, oh my gosh, 3 times 16 is 48, and you knew that right away? Okay? Okay. 3 of you. How many of you thought immediately 6 times 8? And how many of you immediately thought 4 times 12? Okay, so my first thought is 6 times 8. It's one of those math facts that we learned in 3rd grade. Remember when you guys had to do the multiplication times tables? This one was one of the ones you had to do in 3rd grade that you had to memorize on that speed, those math facts that you guys did. These ones are bigger, and so they weren't a math fact, and so they don't always come to our mind as quick. So usually I come up with this one in maybe 2 seconds. And then this one takes me about 2 more seconds to get to. But that one I might not get to at all unless I really think about it for maybe a minute, okay? Because it's not a math fact that I learned. I did do 12s, but I think we learned how to multiply by 12 in 4th or 5th grade. But this one we learned, I think, in 3rd grade. So we just did it more, okay? So, which pair do you want me to do in our example? 16 times 3? Okay, so we rewrite this as a product. We want to pick the biggest square that we can think of. Okay? And I will tell you in my other classes, they did not come up with 3 times 16. Okay, now we want to see if we can square root one of them. I want you to think about it. Don't say it out loud. Show me on your hand. What is the value of the square root of the one we can evaluate? Yes, 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 yes. Yes, 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 yes. Yes, yes. Good. So we can square root 16. The square root of 16 is 4. Okay? So I have square root of 3 times 4. And I will give full credit for that. It is completely simplified. But some students get a little sloppy when they're working. And they'll do this. Okay? And I will think that you think square root of 48 is square root of 3.4. Okay? Some of you will get that 4 really, really close. And I'll think that it's a 34 with a blemish inside your square root. So one of the things that we often do to help the reader see that it's square root of 3 times 4, we often put the 4 in the front. Does this mean the same as this? Don't say it out loud. Thumbs up, thumbs down. Does this mean the same as that? Good. And that's because multiplication is associative. We can switch the factors as long as it's a product. You can switch the order because like 2 times 3 is the same thing as 3 times 4. Okay? So I will give full credit if this is clear that it's not a 3.4. I will give a full credit if I can see that it's not all inside the radical. But I like this better because my brain sees it correct right away. Okay, let's try this one. Number 2. There is something different about number 2 when comparing it with number 1. I want you to think about it silently. What is the difference between 1 and 2? When you think you've got it, just show me a little thumbs up. Okay, got it. Can I get someone new to share with me the difference between the 2?
There's a 3 before the square root, like on it, instead of like number 1, it just has the square root of 48.
Good. So this one we have just a square root, and this one we have a little 3 on it. Does anybody know what the little 3 means? Alyssa? It means a cube, okay? So if it has a little cube there above the little check mark part, what am I going to do different? Shaylin? We're going to... good. We're going to cube root the number or find something that I can cube root, okay? So when I cube root something, that means I want to think of something that when I cube it, it's 48. Now, is there an integer that when I cube it, it's 48? No. So I have to do something similar to here by breaking it apart into two factors. One that is something cubed, and then another number. Okay? Let me give you the fancy vocabulary on this real quick. The little number out here, I'm going to put an N there. That number we refer to as the index. Okay? The index of a radical. The symbol is called a radical. The inside is called a radicand. And that little number there is called an index. Okay? The index tells us how many times we're going to root it. Okay? Or what the power of this we want to try to rewrite it at. So let's try it real quick. 48. If I want to rewrite it as a product of two radicals with a cube root, and the goal is to cube root one of those numbers, which pair am I going to use? Don't say it out loud. Think about it. And then I want you to give me a signal. Option 1, 2, 3, 4, or 5. Which option are you choosing? Good, good, good. Good, good. Good, good. Good, good. Good. What about over here? See me signal. What pair do you think we should use? Everybody that responded gave me this pair. Okay? So I'm going to put that in here, 6 and 8. Okay? All right, this is harder to show. You're going to need 2 hands to show me which factor we can cube root. Okay? 2 hands to show me which factor you can cube root. Yes, 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 yes. Yes, yes. Yes, 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 yes. Good, yes. Good. Yes, good. We can cube root an 8. Now show me with your hands. What is the cube root of 8? Ooh, show me with your hands. Yes, yes, yes. Yes, 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 yes. Yes, 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 yes. There we go. That's better. Yes, 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 yes. We can cube root an 8 and we get a 2. Now I want to make sure it does not look like a cube root of 6.2. I want to make sure that it doesn't look like a cube root of 62. Can you show me real quick on your whiteboard how to make it easy for me to read? Good, except you need the index. Good, except you need the index. Good, good, that looks great, 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 except we need the number. Good, 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 good. Excellent, that was looking good with the cube root. All right, so it is nice, I will give you full credit as long as it's not sloppy, okay? But this is the way you're going to see it on a multiple choice test, because when we are reading, we want it to be as clear to the reader as possible of what the answer is, okay? So on a multiple choice test, you will see it always written with the coefficient in the front, okay? So that's another word that I just mentioned. The index is that little number. Any number that I multiply in front of the radical, and it could be a product with a variable in it. We call this a coefficient. As long as it's a monomial outside, we call it a coefficient. Okay? So those are some fancy terms for us. Okay, let's see here. I'm going to be changing the slide in a minute. I do have this all documented on my Instagram already. Here are a few for you to try as soon as I get my... Okay. I want you to try these. Now, I'm not going to give you a ton of time to try these. I just want you to try 1 or 2. Now, here's a little secret. When I put up these problems, I'm not telling you you need to do all 6. I put up 6 because I have some students that can do one problem in 2 seconds. And so they need 6 problems so that they don't get bored and lose focus. Okay? I put green problems up there for my students who want a challenge. The ones that you really should be focusing on are 2 and 4 because they're brand new. Okay, so my goal is for my students that need more time to think, you're going to get through 1, maybe 2 of those problems, one of which being 2 or 4. Okay, and I'm just going to do a quick little scan to make sure we're all doing good. Let me go see if I can find my answers. Collaborate with your team. Oop, I left my answers at home, but that's okay. Okay, here are my solutions. Okay, I want to get your understanding. Now remember, I wasn't aiming for every single person to get through all 6. I don't think I gave enough time for anybody to do all 6. Real quick, secret thumbs up. Anybody get all 6 already?
No, I only got 5.
Quick hidden thumbs up. Anybody get 5 out of 6? Anybody get 4 out of 6? Okay, see, that's good. So see, in several of the groups, there are students that think super fast thinkers, and they got through 4. My goal is not for everybody to get through 4, okay? My goal is for everybody to feel good about it, okay? So, I want to now see thumbs up. The problems that I got, that I did correctly, or I made a small error, but now I understand it, okay? So thumbs up, you're feeling pretty good right now because you did it, you understand it, or you made a mistake, but you understand it. Thumbs up. Thumbs down, I didn't get it, I need more time.
Why wasn't the last one before I?
Okay, I have a great question on the last one. Why is 6? Why does it not have an I? So I want you guys to all think about it for a moment. And I want to see if anybody has a good thought. Why is there not an I in number 6?
Because you're not square rooting the negative number, you're just taking out.
We're not square rooting. If we square root, absolutely. If there's a negative inside of a square root, absolutely we are going to have a negative. Why does a cube root not need an I? So think about it, and if you think you understand why a cube root does not need it, and you want to share, a little hands up.
I think I have an idea.
All right, I'll give you a chance.
Now there's 3, right?
There's 3.
When you multiply it 3 times, it comes up to function.
Does that make sense what he said? So the cube root of 4, right? We're saying that 218 is a cube root of 2 factors, right? And I know that cube root of 64 times 2 is 128. I can divide by 2 pretty easy. So that's one that I can kind of figure out pretty easy. And then I need a negative. Which of the 2 factors can I cube root? Can I cube root the 64 or the 2? I'm going to call this option 1 or option 2. Which one can we cube root? Show me with your fingers. Good. We can cube root a 64. Okay, now show me on your hand, what is the cube root of 64? Absolutely. Good. All right, now, because I can cube root the 64 and take it out, it's appropriate to put the negative with the 64. Does that make sense? Because if I can take the negative out, let's take it out. It's more simple if it's on the outside. So, we're putting the cube root on this 64. Can I still cube root it? Okay, so, it's hard to do this one with your hands, but if cube root of 64 is 4, what is the cube root of negative 64? Can you show me with a hand signal? Yes. Yes, that looks good. Yes, yes, good. Yes, yes, good. Yes, yes, good. Yes, good. Yes, good. Negative 4. Okay? We can cube root a negative 64 and get a negative 4. And here's why. I'm going to use what William said. He said that if I cube something, I can still get the negative, right? So I'm going to show you guys what he's meaning. Negative 4 times, this means negative 4 times negative 4 times negative 4, right? Okay? Show me with your hands. What's negative 4 times negative 4? Show me with the hand signal. You might need 2 hands to do it. Oh, we can't do it with 2 hands, huh? Okay? Okay? You can give me your digits. It still won't work, huh? I saw this, though. Does that make sense? So 1, 6. You like it? So 1, 6, so 16. Okay, I stole it from you. I did. Okay, so is it a positive or a negative? Positive or negative?
It's a positive.
Okay, so positive 16. Now, I'm going to tell you that 16 times 4 is 64. Okay? But is it positive or negative when I multiply a positive 16 by a negative? Positive or negative? It is a negative. So when I cube something, if I cube a negative value, I still get a negative outcome. Okay? So if I cube root a negative, I don't get I because I can cube something to create a negative. The difference between a cube root and a square root is if I had square root, if I tried to square an 8, a negative 8, to get a 64, squaring a negative 8 would turn a negative 8 times a negative 8 into a positive 64. Right? So the only way to get a negative on there, and I haven't taught you this arithmetic, it might show up later in your careers, is to multiply by negative 8i times negative 8i. Okay?
Why wouldn't that 64 be a positive?
Then it would make it a positive because I would start using imaginary numbers. Okay? But this is arithmetic we used to teach in Algebra 2, which has now been wiped out of our curriculum for the time being. Because it's just a lot. You have a lot you have to learn, so why throw in one extra thing for you to have to learn? Does that make sense? So I could come by and show you if some of you are super passionate about math and want to know the reason why. But I don't want to bombard the rest of you with that because you already have enough to learn. Okay? So great question. Okay, what I want you to do right now, can you please get out the notes packets that you got on Friday? I mean, not Friday, Wednesday. If you didn't pick one up, I have the homework packets here. I'm going to put them right here, here's why. And I have the notes packets here, also in group 1. We are going to flip into our packets. Oh, by the way, the ones we just did, nope, they're not in here. Originally, I wanted them in your notes. But the one that we did with the 48 and the cube root of 48, those are in here. So if you flip to, it says page 4 in your packet. There's a little spot that says summary. It says, how do you rewrite a radical in simplest form? It should be this slide. It's on page 4. I want you to give me a summary. This is an AVID strategy I learned from Mrs. Munkers. And AVID, what's AVID for? How many of you are in AVID?
Follow right
Very
there.
good. Okay, so my AVID student over back there. Okay. AVID is what type of class?
College.
College prep. Guess what? Math 3 is college prep too.
Ooh, I got you. Then
Okay?
I'll keep it, right?
So it makes sense to have college prep strategies used in AVID to help prepare or help this class be better since it's also college prep. okay? College prep means it's a class that's to prepare you for college, okay? So we're going to start using more and more AVID strategies, and Mrs. Munker says if students have a moment to reflect and summarize their thoughts, you are more likely to remember it. So I want you guys to take a few minutes, just 2 quiet minutes, to write me a little statement. How are you going to simplify rational expressions? Okay? And here's a little example here that you can refer to. And I'm going to ask a few of you if I can read them, and I'll read them silently. And then with your permission, if you would allow me to read them out loud, I will do that. Okay? Yeah.
He wants to.
Okay, class, I want to share this one with you. This student said, find multiples of the expression. Okay? Do we do that part first? We find multiples? Okay. Or what's another word that we could use? It means the same thing.
Simplify.
Factors. Find factors, okay? Find 2 numbers that multiply to be the inside number, okay? Determine one with root and lowest common factor. Does that make sense? So we want one of our factors to be something that we can root and another factor. And hopefully we have the lowest factor. I think that's going off of what William was saying. You guys remember where he said we want to use the 16 and the 3 because the 3 was the smallest factor? Okay? Okay? Then we're going to root the factor that we can root and put it on the outside of the square root. And then the other one we're going to keep on the inside. Does that make sense? I like the descriptive words that were used. I like that the student wrote to put the one that we rooted on the outside. And I like that the student said that the parts we can't take out stay on the inside. So I like those descriptive words because that helps us to remember. Some of the common mistakes that I get from students are that they want to square root something and then put it right back inside the radical. Okay? So I'll see this very often where I have a square root of 16 and people say, well, that's square root of 4. Is that true? As soon as you square root it, the radical is gone. It doesn't come back. We aren't square rooting twice. We square root once. Okay? So the one that we are square rooting stays outside the radical. Okay? So if I had this expression here with the square root of 48, this one stays inside because I couldn't square root it, and the one that we could square root it comes out. Yes?
For ones like number 2 that we did,
Uh-huh.
are we like only gonna work with ones that are cubed?
We are primarily going to work with squares and cube roots. The square roots and cube roots are the primary focus in this unit. You will see a few problems with an index that's higher. Like I had one in that example, the challenging problems. Actually, I don't have one there. I have one later on that's going to pop up. It's going to oh, you know, I took them off. They used to be in here. I used to have one with the 5th root, and I had one with the 7th root, just to see how you guys were thinking, but it wasn't on the test. So I took it out because I kind of want to just go over the basics today. Okay, and that is our goal. We are going to spend a lot of time on worksheet 1 today because we really need to understand how to do worksheet 1 because it's the most foundational skill. But then we're going to do worksheets 2, 3, and 4, only the basics, because they're not on the test. Worksheet 1 is on the test. Worksheets 2, 3, and 4 have skills that build up to what we're going to do on worksheet 6, and 6 is on the test. Okay? 5 won't be on the test at all, so I'm not planning to go over that.
Are we gonna take a full test?
I believe it will be a full test, but I'm probably going to take a concept or 2 off. So, okay, so this is part